Hello, everyone, and thanks for joining the Manchester Java community today. I'll start by saying thanks to our sponsor, RecWorks, who cover the meetup fees for the Manchester Java community. We really appreciate this, so thanks to RecWorks for providing this sponsorship. So today we have Michael Mirwaldt joining us, who is a Java backend developer and lives in Munich, Germany. Welcome to the Manchester Java community, Michael.
Thank you.
If anyone has any questions during today's talk, can I just ask that you pop them into the chat area of Zoom, and we'll make sure they get asked either during we're going or while the talk's going, or maybe at the end, depending on the question. Okay, I'll hand over to Michael for his talk on Java streams.
Thank you very much, Jonathan. I hope that with the presentation works as expected. One moment, I have to. So can anybody see my slides?
I can see it fine.
Wonderful. I will keep that chat window here left on the side to see when there are questions, okay?
Okay,
okay, wonderful. I'm really happy to give you that presentation here the first time in English. I gave it to the Chuck Munich and to the Chuck Bonn last time, and they really liked it and told me, please give that talk to other people as well. But first of all, I wanted to start with a question for you, because I'm really interested in which Java version do you use at the moment? And can you just say 11.8, which version into the chat? It's always very interesting for me to see which Java versions all the developers use. Okay, 11, interesting, 8, even 17. Heinz, I'm not surprised that you use an early adapter preview version. I see. And I'm really happy that I don't see here something like 5, 6, or 7, because from time to time, you hear that people use those old Java versions. Okay, wonderful. And now I've got another second question. If you have to weight your skills and experience with Java streams between 0, which would mean I've never heard of it, what is it? And 10 would something like, well, nobody on this planet knows streams more than me. And if you can weight your whether that would be nice. Of course, it would tell me how much you use streams. Wonderful. Okay, 7. Interesting. Well, because that's very useful for me to know, because I said that I don't want to tell you about talk about the basics of Java streams. I expect them, but that's all. Okay, after this session 10, wonderful. Then let's start. So you've seen my title. I know it's a bit ridiculous to talk of Java streams, but I guess everybody of you have seen an expression or use of a stream where you would have liked to start screaming. And that's why I took that as a title. About the motivation for that presentation, well, I want everybody to use and understand streams a bit better, to give them inspiration. And also I want to warn not to overuse streams, because it's quite seducing to use them even if they're not very useful. And I will give you plenty of examples, and I hope there are some examples that you really like and convince you. Okay, about me today. Yeah, first of all, I want to quickly tell you what's my background, so who I am. Then I want to just give you a short list what I think are the basics, which I don't want to tell you much about. Then I want to give you a small list about my personal recommendations. Of course, there are some opinionated, and you might not agree with everything, but it might be interesting for you to think about that. I also want to talk shortly about side effects and how they can be avoided, because I think they're a big danger for streams. And also, I want to remind you with a swimmer on this So big stream expressions that you can split them into pieces. So divide and conquer, and you can apply that to streams as well. I want to show you an example for that. Also, I want to give you examples where I think streams are very useful and where they're less useful, I would say. And last but not least, that's a question of time. I would just talk shortly about checked exceptions with streams, and also how you can debug streams. But that depends on the time. Okay, so who I am? Well, I'm Michael, living in Munich. Some people know Munich because of the Oktoberfest, but in times of Corona, it can't take place at the moment. I studied computer science. I've got programming experience in Java for the last 16 years, so a lot. I was able to contribute some samples to JMH and JC Stress, which are very useful tools, I think, by Alexei Shipilev. And in my leisure time, I play improvisation theater, which I really like, because that's the best exercise for flexibility, spontaneity, intuition, and all that. And it's really a contrast to what I'm doing at the job. And I'm also proud uncle of two cute nieces. And you can find me on GitHub and Twitter. And if you have some questions, wonderful. Good. What do I expect about Java streams as basics? Well, you should know what Java lambdas are and how they look like. Method references. You should somehow know that there are some functional interfaces like supplier, consumer, and there is, of course, operator, but I didn't list here. And you should somehow know those very common intermediate operations like map and filter, and also those terminal operations, collect and reduce. So what are my recommendations for you? Well, I think expressions should not be too long. And if you want a number for me, I would say, don't use more than 5 operations. I know that some people might think of, well, was that not the magic number 7, Miller psychology? Well, this number is not really good if you read about that in Wikipedia, because it is much too high. It is actually dependent on what you learn. And there are many other things. And I think 3, 5, 4 operations, or 5 operations, they're usually quite enough to do something very useful with streams. And 1 operation per line, I hope you noticed that. And Venkat Subramanian once said about that rule, there's only one reason why you shouldn't do that. You hate your colleagues and you don't want them to understand your stream expression. And I think that's quite funny, because there is no really good reason why to put everything into 1 or 2 lines. It's much better and easier to read if you really prefer 1 line per operation. Then I would really recommend you to avoid side effects. What are side effects? I will tell you just in a moment, but side effects make stream expressions hard to understand, hard to evaluate, hard to find the bugs and all that. Try to avoid them. And also the for each operation is often an indicator that you are doing something wrong, or you haven't found the right terminal operation for that. There are some special cases where for each is very useful, but prefer a terminal operation to for each. Also, stream expressions must be easy to understand. That's at least what I say, because if you somehow make them complicated, they actually use your usefulness. And I think you have to keep in mind that before Java 8 and the Java streams, we were programming with for loops and all that, and we were able to do that. And that has not changed. That's all still useful. So streams are only an extension. They are not a replacement for something. And I know that's quite seducing to use stream expressions, but sometimes there's a situation where I could only say don't use them because they will look quite complicated. You will hardly understand it. And there are better ways to do that. I will show you some examples. I owe you some. Also, as a rule of thumb, if you need 5, 10, or half an hour to think of a stream expression for your problem, then I think you shouldn't use a stream expression, because if you are familiar with it and experienced, then this should not take long. And also, when you need to think so long about how to create it, then you will also take everybody so long to understand it later. And stream expressions, they should be read in one glance and understood very fast. And that's you have to keep in mind. Also, divide and conquer is also quite useful for stream expressions, because stream expressions can be longer, but you can always split them. It's really a pity that some people don't think of that very simple element. And I mean, I think there is refactoring one rule that you can introduce explaining variables, and you can do that with streams as well. Also, if you don't know, shall I use a stream or not, then you can just create one solution with a stream and one without it, and just compare them. And if you notice that with the stream is better, then use that one, and otherwise the other one. So just compare them. It usually doesn't take so much time to do that. And if you really want to understand and notice whether another colleague can understand it, just ask him, show him your stream expression and ask him, what does this stream expression? If he needs 1 minute and can tell you what it does, wonderful. If he gives up after 5 or 10 minutes, and be careful, in 6 or 12 months, when you look at the code, you even might not understand your own code anymore. So be careful with it. Okay. Well, what are side effects? Well, I think there are many definitions. My definition here is, this is one kind of side effect, is that you somehow change something outside the stream from inside the stream. And here I would say reading is okay, but not writing, because reading doesn't change something. And there are some situations where you, like this, in this example here, where you want to filter something, and you somehow need something other to compare with. In line 7, you see here that for each, and here you directly change a list. And that's silly for 2 reasons. First, you somehow abuse that for each for a side effect to introduce it. And second, it's not necessary, because there is a good way to do that with the collect to list. And even with Java 16, I think, or 17, there is also, you don't need to write collect to list, you can write to list. There's, I think, a small difference between that, but if you don't write after this line 11 here on the list, I think it doesn't matter for you in most cases. And the lesson here is just look for the right terminal operation. And if it's a problem that you can solve with the stream very good, you will find the right terminal operation. I'm convinced of that. And if not, then it might be something where the stream is not what you actually want. I will give you soon some examples on that, okay? So reading, okay, but not writing, please. And by the way, you cannot change local variables here, because they need to be effectively final. But if you use an atomic integer or something else which is mutable, then this effective final isn't useful anymore. Okay, the second way, or the second kind of side effects, are stateful predicates, stateful functions, stateful lambdas at all. Here's one, for example, that we somehow want to only have always the third element and then sixth element. And what we do here is, because we have no idea to do it better, we somehow use a stateful predicate. And the problem with that here is, first of all, well, look, that filter operation needs line 3, 4, 5, 6. So you need 4 lines. It doesn't fit into 1 line. And it somehow destroys the layout of that stream also, I think, which is also something you don't want to have. But apart from that, well, if you have stateful lambdas, then first it gets a bit difficult to reason about that, because here it is quite clear, you see it. But when the predicate comes from somewhere else, you might not be aware that your predicate is stateful. And last but not least, if you create here a parallel stream with that stateful predicate, you will experience the most strange race conditions that you have ever seen, I guess. So you destroy, or you have to keep be careful with thread safety in this way then at that moment. And also that is a reason why you should really avoid those stateful lambdas. And as you see here in line 9, well, I know it sounds a bit ridiculous, but using the index of method here is quite pragmatic. And if your list is small, well, the performance will be good enough. And I really recommend you in this cases just to be very pragmatic. Okay. Good. So I hope you understood what are side effects and why they are bad and why you should avoid them. Okay. Here is a stream monolith. I will give you, let's say, 30 seconds just to read it and understand it. And I see here, yeah, binary search, but that only works, of course, if your list is sorted. Otherwise, you will also become quite strange results. But I agree that if you have a long list, it might be useful if it is sorted, because in this way, then you can use the binary search, which is even with long lists quite efficient. But that's a good a hint here, Heinz. Okay, I give you now 30 seconds. I'm silent to read this stream expression. It's an opportunity to ring something. Good. I hope you had a chance to read how much is happening here in that stream expression. I must confess that I was not the inventor of this example. I've seen that in different forms on different conferences and wrote my own one here. But you will notice here you have nearly 10 lines if you count line 11 and 12 as well as operation. And I don't think you really understand it on what glance. It takes some time to really notice what happens and how you do that with the top 10 words. And I think here you can really apply divide and conquer. And you will see in just a moment that it really helps, because it's just refactoring and introducing explaining variables. How can you do that? Well, let's first split the first part of the expressions. And if you look here, you see frequency by words, which is a map with string and long. I think it's quite easy now to understand what line 3 and 6 do actually. And the same applies to line 7 and 10 until 10, because now you see that actually we are somehow inversing the map. So what we were before the values are now the keys, because we somehow want not to look up the words, we want to look up the frequencies. Good. I'm sometimes a bit silent because I don't want to talk all the time like an anchorman on TV. Okay, the second split, it gets much easier now because we can use that words by frequency list map, and we just have to look for the first 10 elements. And we do that in line 5. However, we have lists of strings as values, because two words can have the same frequency. And of course, you could say, well, does it really matter if I have top 9 or top 11 in the end? But let's be strict. We really want to have the top 10 words. But we don't make any difference if two words have the same frequency. And here you see a trick. If you look on line 3 and 4, it might look a bit strange, but it's not so difficult to understand. So you see that I use flat map 2 times. First, I somehow create maps, because with only one entry, and then I just take that one entry. And now I somehow do a kind of flattening of the values here. And it's quite pragmatic with that map. We will see a better way in just a moment with the next slide. But you see also here that expression knows the words by the frequencies and just select the top 10. All the other things are in the other variables. And I think that splitting up in this 3 stream expressions can really help you to understand what's happening. Good. So from Java 16, there were records introduced. And I've seen it several times now, and I think it's really nice that you can define records even in your method, where you have the stream expression. And then instead of creating a map and one entry, you can just directly use a record. And here you see that instead of that trick with the map, we do that with the word entry record. And that works fine as well. And it's even one line shorter. And if you are able to use Java 16, I can really recommend those records. Good. So this is divide and conquer, nothing special, but you can use it with streams as well. And nobody should forget that, I think. Good. Now I want to somehow say what I think is typical for streams and then how far they are different from other things. First, keep in mind, streams are expression, no programs. That means expression should be short, while programs can be longer. Don't try to program, don't make your program just one expression. It will be very difficult, hard to understand, because if you do something very interesting in your program, it won't be just one stream expression, just one short one. Also, streamer pipelines, they are not iterators and not loops, and they are not replacements for that neither. So still use iterators and still use loops when they are better than streams. Because iterators, for example, can do something what pipelines shouldn't do, actually, to change the data, the source. Because I'm not sure, but that is something I think high kinds can tell us whether you will get concurrent modification acceptance if you start to somehow delete on lists or on streams from lists or something. And I think the preferred way is still the iterator in this case, and especially, and also loops, they're still useful. That hasn't changed with streams. Then also keep in mind that you usually have really one-dimensional pipeline. And if you have two-dimensional arrays and you have to somehow cannot flatten it to one dimension, then streams won't be very useful. I will give you another example soon. And also keep in mind that you usually get one result from stream, which can, of course, be a list, which is also one result. And you really have to focus on one result here. Don't try to create stream expressions that somehow change two lists and 2, 3, or 4 things at the same time. I think the single responsibility principle also somehow applies to streams as well. And that's why you usually get one result. And also keep in mind that usually you don't change the source. You read it, you filter elements, you map them, you limit the number and so on, but usually you don't change it. And also streams can something what iterators or loops cannot actually, they can be infinite, which is very useful. However, be careful, you have to limit it. I once really did the silly thing that I had an infinite stream. And what I did was I called sorted method. And then after that, I did some other operations, and I was waiting and I was waiting. And then there was a Java out of memory exception. And as you can guess, as the numbers cannot go through the pipeline after it's sorted until they are sorted, there was no way around it. And so it was really a very silly way to, it was really silly to do that. But if you overlook it, then this happens. And last but not least, something quite interesting, Heinz and somebody else noticed on Queed was that if a stream is empty and you just call intermediate operations on it, it's still the pipeline created, although it doesn't need it to be. And I think Heinz created a wonderful blog article about that, and also submitted a PR request. And why I put it here on the list is, be careful when you have many empty streams that you get not any performance problems with it. Keep in mind, empty streams also create pipelines at the moment. I hope that will change with Heinz pull request. Okay. I want to give you many examples first, where I think streams are very useful. And then I will give you some examples where you might not be convinced with every example, but you will notice that streams are not very good for them. Okay. First, there are traditional queries. So if you see the look on the above one, I think that's what you usually do. Okay, Heinz. That's a pity, because I think you made many efforts for that. It's really a pity. Okay. Okay. You see this expression, and I think it's quite typical that many expressions somehow first do a filter. And here you see we are just using a range, like it's with German authorities, where the first civil citizen uses from A to M, and the other one, the names from J to Z, for example, here. Then you sometimes map them, and then you just collect them. I think that's very often the case. And they're very useful, I think, those streams. Also, converting strings, for example, can also be quite useful. I recently had the situation that I had some kind of module name with those dash signs here as a delimiter here. And you see, I wanted to have camel case notation in the end. And I think this stream is very, very nice here, because with the skip 2, you say, well, the first 2 tokens are not interesting, the project and the process. Then you just map it and say, well, the first letter must be uppercase and the rest can be lowercase. And last but not least, you just join them together. And I think that's quite nice that you can do things like that here. And that's, I think, also quite a very useful use case. Okay. Good. Okay. Another use case for streams is, in my view, checks, because those streams have those very useful 3 terminal operations: all match, any match, non-match. And if you look here, what happens, I give you just 30 seconds, okay? And then I will tell you what I mean. Okay, I hope everybody noticed that here we get a list of strings, which should be passed to numbers and then in the end summed up. Of course, you could just map it to ints as it happens here in line 4 and then somehow rely on that number format exception. But I think that's not a good option here because you can here just do first the check. And if you notice one of those numbers, or one of those strings is not a number, then you can just select the first one and throw an illegal argument exception, tell which number you don't like here. And you see also here, there's another stream expression where you just get the first element. And that's what I often use here, all match or non-match, just to do a first check on the elements. I think that's very useful. Okay. From time to time, you have to, for example, merge two maps or other data. And have a look here. Good. You see here you have two maps. You want to somehow merge them. And you want to have the minimum in this case. It can also be the maximum or other criteria, how you want to merge it. And the nice thing is here that you somehow create a stream of all those maps, which could be 3 or 4 maps. It doesn't matter in this case. And you just flatten them and then just put them, collect them, and you just choose the minimums. And that's also something I think which is very useful here. And I think sorted maps are not the only data structure where you have to merge data. Good. Infinite streams. Have a look on that, what happens here. And by the way, that prime check here below in line 7 and until 12, I know it's primitive. Nobody would use it. The Webb and Miller test, I think everybody heard of you, would be quite more efficient. And I think in big integer, you can ask whether it's a prime and tell with which probability. So there are better ways, but we don't care about performance here, okay? So good, you see here, the wonderful, what I like here on that stream most is you don't have to tell an upper bound here because the limit in line 3 here with the 100 prime numbers, well, the prime number doesn't need to be 541. It could be 1026 or whatever. No, 6 would be an even number, but let's say 1021 or something. And you don't need an upper bound here. Okay, there's a question what box means. Well, the unfortunate problem is that we want to have it in a list. And there is not yet a list of int, there's only a list of integers. And so we have to box them here. However, this will change, I hope, at least with Valhalla, where you will have value types, and those value types will be, I hope, supported by lists as well, where they can, the list also support primitive types. And well, okay, value of. I think that's a different slide where you would, Oh, okay. Yeah. Well, that's yes. In this case, you're right, Heinz. This is a shorthand. That's wonderful. I think that's a good way to explain it. But as I said, I hope that this will change with Valhalla in the next Java versions. I'm pretty confident. Good. So that's also something very, very useful. And last but not least, I know that Heinz once said, for what do we need really map multi? And I was thinking about some time about that. And here I'll give you an example with a tree, you see. And I'm just silent for 30 seconds so that you can read it. Okay, you notice that here we have a kind of primitive tree by lists of lists of lists and so on. Yeah, Heinz, I'm pretty sure I can understand that flat map is complicated for some people, that you somehow flatten two-dimensional things to one dimension, and I hear you can have an arbitrary number of dimension actually. But you see here, what I really like with that map multi is that it's actually a generalization, I think, or broader operation than flat map, which is really somehow restricted to two dimensions. But as you see here, it's actually a visitor pattern, or it looks like the visitor, which is supported by the map multifunction for streams. And what I really like here is two things. First, you have a way to somehow recursively visit elements of a tree. And also you can use the stream operations like limit 4, because the limit 4, as you see here, it stops with where the list of 5 and 4, 4 and 5, and you don't consider the 5 anymore. And you don't matter whether how deep that structure is. Of course, you can ask now, well, where should I use something like this? And I would say, well, think of a JSON. Think of a JSON with nested objects, and you are just interested to some objects with a special key, and you only want to somehow visit them and do something with them. And I think nesting is quite often happening with JSONs, and here you have a support for that kind of hierarchy structures. And I think that's useful, but you don't often have trees here. I must say to the question, any book to learn and understand all these syntax, it depends, of course. I've seen that there are many Java docs in where you get more and more small examples how you can use some simple operations of streams. And if you look, I think, to the Java doc of the multi, I think you see a small example. And also that's a good idea, lambdafact.org by Heinz. So there are some resources to it. So look to them, and there are, of course, some books where you can read more about streams. And I think Maurice Naftalin also published one, which is quite useful, and I've read it. However, I think you don't find something about map multi in it because it's quite new. But there are some very good references, and I think Angelika Langer also wrote a tutorial and a fact about streams, which is also useful. I will later give you the link, okay? I don't want to spend time looking for it at the moment on my computer. Okay, I must say, unfortunately, now we get, I wouldn't say into hell, but into situations where I think don't use streams for that. And of course, that's opinionated and somehow biased. Make your own opinion of that, but I hope you can follow me to some degree. So first, have a look on that. Why do I have us just look on it first? So why is it a sad smiley above and a quitting smiley below? Well, when I see something like this here, then the question is, why do I need here a stream to iterate over those elements? And the first thing, as I told you before, we just put a code block here with 2 statements into a stream where we would usually expect only a one-liner or one operation. And that makes somehow look that stream a bit ugly. But what I more dislike here is actually you don't need that stream, because that below does exactly the same. And I would say that for loops like the below, it's quite common to use more than one statement. If you have 2 or 3 or 5 statements, and the below does exactly the same actually what that above does, but that above looks ugly and you don't actually need that stream for. It's quite useless. At least I think so about. And I think you should just use that below one. Just use streams when you really use things where streams are useful, where you use a filter or whatever. But if you don't use it just for each, I don't think you need it. I know that's my opinion. Okay, next examples. First have a look on that above and then on that below. Okay, we have a question. Is it a problem if we alter the value of a stream element? I'm doing, for example, yeah, I've seen that, but I would be very careful. As I said, this is a kind of side effect. And I'm not sure whether you would expect when you iterate over apparently a map where you change the entry, whether you really notice that you are doing that and really following that this happens here. And if you don't expect it, it will be very surprising for you. And that's why I would be very, very careful to somehow do kind of tricks by being able to set the value of entries when you iterate over them with the stream. I would not recommend it because it will be very difficult. So you can do it, but I wouldn't recommend it to you. Okay. So you see here, or both, that's what I meant before, and where it's really pity that Heinz pull request is not accepted, because here, if you use Java object layout, another wonderful tool by Alexei Shipilev, where you can see the memory footprint, you will notice that this expression, I think it takes about 100 bytes, which is not very much. But if you create 1 million of those empty streams that you create here and just throw them away, you won't like it. You're really busy the garbage collector maybe in a way that you don't want. And you see here from the beginning, we have an empty stream. And as it is empty, it will never be non-empty. And that's why we will never need this pipeline here. However, streams are unfortunately only lazy evaluating, but not lazy build. And yeah, Heinz is right when he says, well, you somehow have to detect if you have an empty stream and then just really avoid calling those intermediate operations. But by the way, I also found a solution with lazy build streams, I call them, where I really try to somehow notice it. But my approach has the problem that you have always to somehow decorate those streams. Otherwise, it won't work. So that there are different ideas, but I agree you have to just keep aware that empty streams create pipelines they don't need. Okay, next here I'll show you iterator that just removes always the third element, and I showed it here to you because that's, I think, what iterators are made of, that you iterate over those objects and you can also remove those objects. And I don't see any reason why you need to do somehow something like this with a stream. Iterators still are good. So keep that in mind. The iterator could be a wonderful alternative to a stream. Okay. I talked about the one-dimensional and multi-dimensional. Think of here about that matrix transpose, transposing a matrix. I'll give you 30 seconds to read that code and understand it, and then I comment it, okay? So good. If you read that, you notice that we are actually swapping elements at different positions. And here we only need to iterate over the lower triangle. So 1, 2, 3, 6, 9 here, as you see, and we only have to swap the 4 and the 2, the 7 and the 3. So in the line 10 and 12 until 12, and the 6 and the 8. And I cannot imagine how you do that with a stream, and I actually don't want to see how that would work. Okay. Yeah, there are many opportunities to do that, but yeah, that's interesting. Yeah, but you are right, Heinz. You can do it in a different way as well. But I hope you agree that you don't want to do that with a stream. Those two loops are wonderful for that, and swapping here is wonderful, and you don't need a stream for that. That's what I want to tell you here. Good. Then sometimes you see something like this. Have a read. Good. For those who've not really understood what happens here, it's a good message actually, because you don't want to write streams like that and try to understand streams like that, because what actually happens here is that you somehow abuse that int stream to generate your index numbers where you change the values. And in the reduce method, you don't actually use the numbers of the int streams directly, you just use them as an index. And okay, whether this would work with parallel, you mean that example before this example here? You mean this example here? I'm not sure, I must confess, because that's really something I would like to try out after the session here, because that's really interesting. But I feel it won't. It's just a gut feeling. However, here what I wanted to say is you don't do a reduction on the in-stream numbers. You do a reduction on that array that you introduce here, which you need, because if you reduce something, you usually only know the predecessor and not the predecessor of the predecessor. So you have a kind of, you need more history for that. And here for Fibonacci, you need 2 elements as your history. And that's why this reduction does not really work actually. And that's also an indicator that the stream is not very useful here. And why I dislike this example is the reason is this here. You can write the same code here with actually 5 lines with just a single array, just a single loop with only one assignment that tells you how you calculate the Fibonacci numbers. And the only difficult thing is here to keep in mind that you work with remainders of 3. So why do you need here a stream? And you know, there are many other examples as well. And I think it's an anti-pattern when you create an int stream only to somehow have a for loop with an integer. But you see it very often, unfortunately. That is at least my experience. But you see here, I think that's cute, this code. And it's short. And it exactly tells you how you calculate those numbers. So have a look once again here, and have a look on here. Good. Then I want to shortly talk about one, let's say, controversial solution, how to deal with checked exceptions. Can I ask you shortly to enter Y for yes and no, N for no, whether you have heard about Sneaky, the sneaky throw hack? Okay. Interesting. Many don't know it, and I think that's good. And that should be like this, or keep that like this, because first it's controversial here. Have a look for 30 seconds what happens here. Then I comment it, okay? Okay, this is a bit strange here, because I don't think many people know why this works here. And the reason is the following. In the Java language specification, I think in chapter 11, part 2, there is a problem with type inference. And as far as I understood it, you might get the problem when you try to infer types of exceptions, that you might not really know which kind of exception you have. And in this case, your Java virtual machine assumes that it is just a one-time exception, because one-time exceptions are less difficult than checked exceptions, which you have to somehow declare in all the declarations of the signatures of your methods. And here you somehow can cast a checked exception to a one-time exception without creating a one-time exception. And you somehow save creating one word, but of course you don't save creating the stack trace, which is actually, in my opinion, the most expensive on exceptions. And I think Brian Götz, you know, the Java language architect, was once asked about that, and he said, "Oh no, please don't use it," something like this. It was not those words, but he was not happy that people noticed that and use it. And also, it's a kind of leak, which might be fixed in a future version of the Java language specification, and then this will not work anymore. And that's why I would recommend not to use it, because there's, again, a solution we use all the time, or nearly all the time, to deal with checked exceptions we don't like. And as you guess, why just not create a one-time exception and give it the checked exceptions as cause? Because this, I think, will always work. It's not, you not somehow abuse something from the Java language specification. And also, you use it, I guess, in different other contexts as well. So why not use them in with streams if you if checked exception bother you? So have a look here. Ah, interesting, Heinz. Yeah, I can think of that. It's rather important for the compilation whether it's a checked exception or not. Good. So you see here, you just create a one-time exception if it is a checked exception, and if it is already a one-time exception, you just can just read through it. So it's so simple and still works. So I don't think you need to sneaky through. Okay. Last but not least, I think we are on 1 hour. How about the time, Jonathan? I can't hear you.
Can you hear me okay now?
Yeah, wonderful.
Yeah, we're okay for the time.
Okay. Otherwise, I would have just skipped that with the debug, but it's only 2 slides. Okay. There are 2 ways how you can debug stream expressions. The first one is here that there is the need peak method, which just takes gets a consumer, and often this consumer can be something like system or print line if it is not in production code or kind of logging, so that you can somehow output the intermediate results here. However, 2 things you have to keep in mind. First, this peak method is really only considered for debugging. It's not considered that you use it for something else. Because second, you don't get the promise that it is called at all. If you look carefully in the Java doc, you will notice that there is a statement like, if this peak method prevents an optimization, then the OpenJDK developers will have the freedom not to call the peak method. And that's why you cannot rely that this peak method is always called. In most cases, I think it is called, and you can use it, but don't rely on that. Really only use it for debugging. Okay. And last but not least, there is a window. I don't know whether you have noticed that. There is a button below. You see that on the bottom line, that wet rectangle with rounded edges. You can use that to see when you have a breakpoint in a stream expression, what are the intermediate results of it. And I think this visualization here in IntelliJ is very nice actually, but of course it only works when you have not long streams with many operations. And also it only works at the moment, I think, for simple stream expressions. I think recently I've used collect reduce and it didn't work. I got a kind of null pointer exception or something, but it didn't work. But I think this will be improved in future, and I think it's really a nice feature. Because here you see on the left, we have that now those numbers from 2 to 13, and then after the filter, every number after 7 is missing, and then we get the binary representation of them, and then we get a list. So I think it's quite useful. I must confess, however, I haven't noticed, I don't use any more Eclipse, and I don't know how the Eclipse users are equipped with smart tools to debug stream expressions. Okay, I hope it was not like a typewriter or an anchorman putting all the time words on you. That's why I give pauses. And also you can have a look on those examples if you want to try them out on your own here on that link. One moment, I will put it to the chat. And of course, thanks for your attention. And if you have some ideas or some feedback, then we have some time for it, Jonathan, right?
Yep, sure. We still have time.
So if something was too fast for you, or you have some other ideas or aspects you want to talk about, then just tell me. I'm always very open to feedback. But thank you very much, really. I hope you now think about next time when to use streams and how to use streams, and really benefit a lot from streams and not suffer from bad stream expressions anymore.
We've had one question come in.
Okay. First, I will read it. Thank you. It was very interesting, a lot to learn. Just your newbie question. How do you check if the stream is empty if you don't build the pipeline? Do you mean something stream? Well, I don't know how. Well, there are different ways. One way I tried out with lazy build streams was that you can create a split iterator from it, but it is a terminal operation. So you have somehow wasted your stream. However, this split iterator has a method which tells you how many elements, or if it has elements at all. And you can then use that split iterator and create a new stream with, I think, the stream util operation. And then you can check whether you really need a stream or whether it's still empty. I know that it's a bit clumsy because streams are not made to be reused. Whenever you use a stream, the second time you will get an exception which says something like it is closed or it has been used yet. But I think using the split iterator and then embedding it once again in a stream would work without wasting the stream. Okay, some other question. I hope that helps you. I know that it's a bit clumsy, but that's the way it is at the moment. It's interesting that you say that with the parallel stream. I don't know how Kynes thinks about that, but I don't want to sound arrogant when I say those parallel streams are only for professionals for two reasons. First, I think you don't use them very often. I hardly use them actually, because I always so small data that it wouldn't be useful to use a parallel stream. However, the problem with parallel streams is that you somehow have to really analyze what you're doing and in how far you can really split it into different portions and really to process them in parallel. And there are some problems like, how do you split the best way? And also, how do you get the result? If you have to merge many lists together, then this will be a big pain. It will cost you a lot from the performance that you got before. And that's a problem with the parallel stream, that it's quite seducing just to call parallel or parallel stream. But I'm afraid that in most situations, especially with small data, it will be slower, not faster. And if you really want to have it faster, you have to really analyze and think about it. And there are many considerations. You have to measure a lot. And that makes it very complicated, I think, to use parallel streams. But if you really know what you're doing and really have a good split strategy and also have a good way to merge your results, you can benefit a lot because you don't need to use the fork join pool yourself. But also keep in mind, if you want to parallelize something And you should not think, well, I have to make a stream out of it to use the parallel stream, because in some situation, directly using the fork join pool would be a better option because you have more control over it. And yeah, that's why it kinds that you really need a lot of data and you really need to know what you do. And then you can benefit a lot from it, but otherwise keep your fingers away. Okay, any other questions so far? And by the way, I am preparing at the moment our presentation. I would call it Java's Dreams. Oh, you mean Java's Dreams? Java for the professionals, where Summer would like to collect some good examples where you can really see where parallel streams are useful and where they are not, and what you need to consider. And but at the moment, I'm really looking for good examples, because you will always find everywhere in the web examples, but many are not really very convincing, I think. And that's always the problem with examples. When they're really bad, they actually make you not use something. Okay, Jonathan?
Yeah.
What is the time, or what do you think?
If anybody's got any more questions, I think we've still got time if you're willing to answer them. I think a few people have dropped off that couldn't make it anyway.
By the way, before the question comes, those slides that I showed you now, they are not yet published. I will publish them today evening on that GitHub page, and I will give it a password because I don't want not everybody to copy that without. But I will put it under the meetup and the meetup comments. Is that okay, Jonathan?
Yeah, that's absolutely fine if you want to put it in the comments.
And then you can look at, and as I said, if you look on that GitHub repo, you will find those examples, try them out, maybe experiment with them a bit. And I always, constructive feedback, I'm always open to it. I'm not sure whether all the examples are perfect, but if you have some ideas, thank you. It would be nice. But I think they are quite good.
Okay, I don't think there's any more questions come in. Okay, so I think we'll, unless somebody puts anything in, I think we'll start to wrap up.
Okay. So, Jonathan, I don't know, what I would like to see or talk about, just 5 or 10 minutes, if you don't mind, what's your experience about streams? I'm not you, Jonathan, but the people that they might be somehow right into the chat. Well, I have good experience with this sum method or something like that. It would be quite interesting for me. I don't know whether it's interesting for you.
Yeah, we've got the time. So if anybody would like to contribute.
So it would be very interesting for me, for example, where you had the biggest benefit from streams and what were the worst streams that you have ever seen. I think most of them have parallel stream in it. Sorry to say that, but that would be quite interesting for me. Because I really like to use streams, but I noticed that overusing them is really quite bad because, you know, I don't know, I think there are some features in programming languages which get a bad reputation because they are overused and obsessed, and people use it too many times too long, and then after some time, people don't like it anymore. And my motivation for this presentation also was, don't overuse them, use them where they are useful. Good, I think there's nothing coming yet, but that doesn't matter. But thank you very much, Jonathan, for giving me you that talk. I hope you appreciate it.
Yeah, very much so.
And I'm wondering at the moment, can you recommend it? Would you think that other chucks also should watch that presentation?
I think if nothing else is a good indicator, this has been an extremely, the take-up of people wanting to join this has been one of the best we've had.
Really?
So
Okay.
I think that shows this is an interesting topic for people in the, especially in the Manchester Java community at least. So I think it's definitely worth looking to give this talk elsewhere.
Thank you very much. I really appreciate it. And as I said, I'm preparing that for professionals, and I hope it will be as good as this one. And if you want, I can offer you when it is finished and when I have good feedback for it.
I was going to say, keep us in mind whenever that is available. We gladly have you back at the Manchester Java community.
Thank you very much. And thank you all for attending that and all your feedback. And thank you also, Heinz, for your ideas in it. Thank you very much. And see you next time.
Okay. Thanks for joining us, Michael. Just a quick to point out, hopefully the video of today's talk will be up on the YouTube channel in the next few days. So keep an eye out on our Twitter account and the Manchester Java Community YouTube channel for that to go up. And thanks everyone for attending.
So see you next time.
Thank you.
Bye-bye.